Okay, in the last video we made the last two videos we made text and then we made the text move around the screen. This video, in the seventh video, we are going to make a player sprite, and then we're going to actually control the movement of this player sprite. So we are continuing on right from where we left off in the last video. If you're just joining for this video, we are using my repo here called SDL2 examples. Just clone the repo. We're in the C directory, the C SDL2 directory, and we are working from 06, the moving text. This is where we're starting. We're going to be moving on. That's going to be 07 today, but we're continuing on from this 06 right here. So let's do that. So 6, so we're going to copy that line, and we're going to paste it, and we'll call it player sprite. How about that? Player sprite, and we'll make sure we actually use this file. So we'll just close the other one. So that takes care of that. We'll change the title here again. Okay, so we're going to be doing two things in this video. First, we're going to be loading a new image with a rectangle and everything, but we've already done these steps before, so this will be pretty quick. And the second thing is we're going to be moving it, but we're going to be using the direction keys, but not in the way that we used keys before. This way, we're going to actually be checking, is the key still down? And we don't want to know if it was pressed down. We want to know just in this frame, is it down right now? So it's going to be a different method. It's for smooth movement, so it doesn't do the thing where you press the key down once and it waits a second and then it starts repeating. It's not going to do that. It's just going to, every frame, if it's down, it's going to continue on. So the first thing we're doing is loading in the image, and it's what we've already done before. We've loaded the background image. So we're going to need a couple things. We're going to need an SDL texture to hold the image. We're going to need an SDL rect, and we are going to need just a single velocity because we're just going to use that for its speed. So we'll just add those in right away. And it's going to be SDL texture. We'll call this a sprite image. SDL rect. And this is going to be sprite. And how about velocity? So this will just be an int. And we'll say sprite vel. Okay, so this one here, this texture image, is something that needs to be managed. This is a resource that's being put on the heap, so we need to manage it. These other two, this is just standard int, and the rect is just a struct that's going to be on the stack. So let's take care of initializing and then destroying these resources. Sprite rect, and we'll initialize this rect as well, just to zeros. And I don't know what we want the speed to be. We could pick 3 or 5. We pick 3 for the text. If we want this to go faster, we can pick 5. I'll put it on 5, but you can change it. Now I'm not using xvel or yvel because it's just overall velocity. It's not really going to matter which one it is. And we'll set that to 5. Okay, so we have this. We are initializing the image, but we need to deal with the fact that it's going to need to be cleaned up. And we've already seen all this stuff before. This is destroy. Destroy texture. And it's going to be game sprite image. Okay, that's the only one that's managed here. And we are not bringing any new systems in. We don't need anything else in initialization, but we do need to load in the image that we're using. And the image is over here, this C logo. That's the image that we're going to be using. So it's going to be exactly the way that we loaded in the background. And we'll call this, should we call it Sprite? Oh, yeah, we already have a name for it, Sprite image. C logo. Okay. Sprite image, error creating texture is fine. Image, yes, that's fine. Okay, so now this is going to load in our image so that we can use it. But we need a texture, and the way that we need a rect for a texture, because we're not going to be drawing this to the entire screen like we did the background. And the way we did it with text, we initially started with the surface, so we actually pulled the width and the height from the surface. Now we're loading this directly into a texture this time, so we can't just pull the width and the height straight out of it. We need to actually use another function that is going to query the texture. So let's look at that function. So SDL query texture. On this one, we're sending in the texture. So the format and the access, we're going to leave those both as null. This target can be null if you don't need to use this information. We don't need it. We just need width and height. That's all we need. So we're going to leave both of these two, the format and the access, as null, because what we actually want out of this, we just want to find out what is the width and the height of this texture. So we're going to send in the texture itself. We're going to hit null on these two options. And then here we need to send in a reference, because it's asking for a pointer. So we're going to send in a reference to the rect's width and the rect height. And that's how we're going to populate those two. And this is going to return 0 on success or a negative number. And we will, this seems kind of important. It's not like the drawing one that's happening every frame. We actually need to know about this rect. So I'm going to let this, if it fails, to shut the program down and clean up. So we'll wrap this, since this is returning 0 on success, we'll wrap it in an if statement. And the texture we're sending in is the game sprite image. Yep. And then we got null for both of these guys. Now these two are different, because these, we need to send in the game sprite rect w and h, but we need to send in the reference to them because it's actually changing it. So we're not going to send in it. We're not sending it in as a value. We're sending the address in because we actually need to change it inside of this function. So it's going to be the game sprite rect dot width, but we need the address of this guy. And the same for the height. Sprite rect dot h. Yes, yes, yes. Oops, I want to close this guy. There we go. Okay, is this inside this? Okay, so if this doesn't return 0, we want to kind of bail out and clean up, because we do need that. This is a one-time thing. We do need to deal with this. Oh, that's not what I wanted. Okay, so querying texture, say. Querying texture, and this will just be the SDL right here. Okay, I'm just making sure that that's image. That is SDL. Yeah, we haven't messed any of that up. So there we go. So now we're populating our width and our height. And that's how we're getting those. So we have an image, we have a thing. Let's just display it real quick before we go any further. And the way that we're going to do that is just the way that we've been doing everything else. It's going to be exactly like this guy right here. And this, it will be Sprite image. And we are taking the whole of our source image, so that's still going to be null. But the target is going to be, or the destination rect is going to be the one that we've just populated. Where that's, so if it, say if our image was, say, 20 wide and 10 tall, and when we're drawing it to the screen, we want the entire image, so we're passing in null from our source. But our destination on the renderer, we need that 20 wide by 10 tall, so that's why this is the destination rect. And we get to move this rect around, so the image gets displayed in different spot on the render. Okay, so yeah, so we should just see our image loading and being displayed now, and it should be in the top left-hand corner. I did change the name and all that stuff is correct. Double checking, and we are cleaning up. Okay. Let's just make this bigger. 7. Sprite. Okay, and there is our Sprite right there, the C logo. So now we need to move it around. Now we have been using the up here in our loop, our event loop, we're checking if an action has occurred. And if we use it this way, we'll get this thing. It's like, well, it's like this right here. Say up here, if I go to type in A, I'll get an A and a pause, and then I'll get a repeating A. See that? So that is just saying, the keyboard is saying, hey, I think that you want more than one of them. Initially, it just says 1. I don't want to keep pressing it because maybe you accidentally pressed it down a little too long. But after half a second, it says, oh, you really do want more than one of these. And it's going to start repeating it. And that's what's going to happen in here. It's going to start repeating this key up to key down action. And that's not how we want the game to happen. I want every single time I come through this entire game loop, I want to know, is that key in the down state? Do you still want to move this time? I don't want it to be something about the system or the computer or the keyboard telling me that there may or may not be a repeating action happening. So this is going to be, there's SDL has an internal array that basically has all the keys in it, and it's just going to be 0 or 1 whether it's pressed or not. We'll take a look at that. So this function, SDL get keyboard state, this is going to give us a pointer as to an internal array. And this array is, imagine however many keys you got. Say you have 110 keys or something. It's an array of 110 keys. And these keys will be 0 if they're not pressed or 1 if they are pressed. And we actually index this array with the SDL scan code, just like the scan code that we used before to check if the key was down. These same scan codes are actually used to index that array. So imagine these scan codes are, say, an enum, and depending on what scan code you put in, say SDL scan code space bar or whatever, or space, it'll that will be that scan code will actually be the index into the array to tell you if that key is down or not. It's not telling you has it been pressed down, it's just telling you is it down. And this is a pointer to an internal array, so it's not something we need to manage. We can just make this pointer one time and we can just keep using this pointer the entire time. So we're going to create this pointer once, we're going to populate it once, but it's going to live through the lifetime of the program, but we do not need to deal with cleaning it up. This is an internal array for SDL. Say it's a pointer. So the array elements have a value of 1, meaning the key is pressed, or 0 if it's not. And we have the same scan codes that we've seen before. Yeah, we've seen these before. Okay. So we're going to basically make a, what do we call it? Key state or something like that? Yeah, key state. So we'll just add a key state into our game struct and we'll populate it, but this is not something we need to manage. This is not like textures or surfaces, other things like that. This isn't managed by us, and this is just an array. It's just a pointer to an array. So yeah. So it's just a unsigned 8-bit integer. uint8. And that type is defined in the SDL library. So this type right here, we're just gonna take this whole thing for a second. So right here, I'm gonna just paste this for a second, but I'm not gonna use all of it. I just want the type. And we're gonna call this key state. Yeah. So it is a const, it's a const pointer to an unsigned 8, So we're gonna just populate it right here. Key state equals, and we'll just put null into it. I'm not sure if it said it there. Key numbers. If non-null receives the length of the returning array. So yeah, it's going to be null because we just want the array itself, or we just want a pointer to the array. So we are just running the function there. That's going to populate our pointer, and we don't have to worry about cleaning up this resource. It's just right there. It's just a pointer to an internal array, and we're just going to index it with those scan codes. So that's how we're going to get our movement. So we'll make a new function down here. Just like we were updating our text, we can update our sprite. And nothing important is happening in this one either, so it's going to also be void. So this one, it's just going to be a couple if statements, and basically we are just checking if the we're going to use the whatever key that we want to check. We're going to use that as the index into the array to see if it's pressed or not. And we can set multiple at the same time. So I'll just show you how it's done real quick. So we need to use the key state. And now we're going to index into it, and we can use, so the scan codes for left, right, up, and down are just literally left, right, up, and down. So let's just up, about easier one to find left. There we go. That's the one we're looking for. SDL scan code left. It's going to be an up, down, left, right. There's also an A. If we wanted to use WASD, we can use those as well. So we're checking for, let's check for right. Yeah. Or we can do left first. How about that? So if this is true, we're going to do the action. But we could also use a logical OR and check the A letter as well. Like that. So that's going to check if either one of these happens. And what are we going to do? Well, let's just update the Sprite's X member, the Sprite's rectangle X member, with the Sprite velocity, and we'll put it on the positive. So we'll go game Sprite rect dot x plus equals game, sorry, velocity. Yeah, just like that. So that should get us moving to the right at the speed of 5 pixels per frame. So let's just try that real quick. So I've made a mistake. Let's see, somewhere up here I got some kind of, okay. Right here, put a semicolon on accident. Okay, so we want to see that C moving to the right. I'm going to press the left, sorry. I'm going to press the left arrow, and that didn't work. I'm going to press A, and that also did not work. Oh, I know why. Because we're not actually calling this function. So if we, so we've made this function down here, but we haven't actually called it in the loop. So we can update the text, and then we can update the sprite as well. Okay, and we need to forward declare it. Okay, so I'm pressing the left arrow key. I'm moving the wrong way, but it's working every time I press it. Now I press the A. Yep. So it should have been a minus equals instead of a plus equals, but we know that both keys are working. So let's go down there. We can fix that and add the other ones in real quick. So let's just copy this. All right, so if we went right, we would be adding. And we'll do the D key. Okay. Left, right, up and down. Do up and W. And this one we need to change the Y. And it needs to be same negative velocity. And the Okay, so I'm pressing the right key, right arrow. Yep. Left arrow. Yep. Down arrow. Up arrow. Okay. The D. Yep. W. S. A. I'm going to try two. I'm going to try left and right at the same time just to see what happens. Cool. Just left, left and right. Just right. Yep. Okay. Up and down. Yep. Diagonal. That's fine. That's what I want to happen. I don't want it to move if the opposite directions are being pressed. Okay. So I think that is it. Let's just walk through again what we've done here. And we still have our colors and stuff. So basically we have just added, we have a sprite image, we have a sprite rect, we have a velocity, and we have this new pointer to this internal state of the keyboard. It's an array to an internal array. And although we are declaring it up here, we're just actually setting the value of that pointer right here directly, and that just stays for the life of the game or the life of the program. So we're doing that. We are loading in just like we have before a texture. So nothing new or interesting is happening here, but down here we're querying it. So up here we were able to get the information from a surface directly, but here we need to run a function where we need to pass in the reference to the width and the height, and also this is something that can fail. So we got that, and then the way we move things is with that key state by using the scan codes as indexes into it. So it's this index is either going to return a 0 or 1, and we're basically saying, hey, is this one or is this one? If either one of them are, we're going to do the thing. And we're just changing the x again or the y, and we're doing it with the velocity that we set above, which is 5. So it's moving a little faster than the text, because we set the text to move at a speed of 3, and that's each frame, so it's happening 60 times. So this one is going to be 300, I think 300 pixels per second, something like that. So that is going to be it for this one. That is a different, the way that you would actually want to move controllable characters. You're going to want to use this way, not the event loop. If it's just a key press action, like say pulling a trigger or opening a menu or something like that, you're going to want to use the event. But if it's you're moving because it's being held down, you want to use this other method down here. This is going to be what you're using for something where you're holding a key down to make an action continually happen. And we're not checking if it's off the screen and all that, because we're the ones controlling this character, whereas up here it's just bouncing around the screen. Okay, so I hope that was explained pretty well, and I hope you enjoyed the video. Okay, and bye.